Since ancient times, astronomers have always known that galaxies are not stationary but move at extremely high speeds. According to Hubble's law, galaxies are moving farther apart at a rate proportional to their distance. However, by 1986, astronomers had discovered a strange gravitational phenomenon in intergalactic space, known as the Great Attractor. This colossal gravitational pull is located about 220 million light-years away from us and has a force so strong it can dictate the trajectories of tens of thousands of galaxies. So what is it? Why does it have such immense power? And how will it affect our galaxy? In this world, all things are in constant motion and transformation. On a cosmic scale, these movements become even more intense and magnificent by orders of magnitude. The theory of universal gravitation shows that the magnitude of gravitational force is generally proportional to the mass of celestial bodies. For example, in the Moon-Earth system, because Earth has a greater mass than the Moon is pulled by Earth's gravitational force and orbits around it. In the Solar System, the Sun accounts for nearly all of the mass and serves as the gravitational center of the entire system. As humanity continues to expand its journey of exploring the universe, we have discovered countless star systems with structures similar to our solar system, collectively forming the vast Milky Way. Additionally, at the center of the Milky Way lies a supermassive black hole. Its immense gravitational force keeps countless star systems, including those similar to our solar system, orbiting around it. However, the Milky Way is not the end of the universe. On a larger scale, structures such as galaxy clusters and superclusters exist. In academia, celestial bodies influenced by the same gravitational force are often regarded as a system for study. Recent studies and observations have confirmed the existence of a gravitational anomaly at the center of the Laniakea supercluster, believed to be an extremely large-scale gravitational source. This gravitational source is called the Great Attractor. When it comes to exploring major attractions, humanity's journey to conquer the cosmos cannot go unmentioned. Initially, humans primarily relied on observation to explore the universe. When the Big Bang theory was recognized as the mainstream theory of the origin of the universe, thermal radiation, a remnant of this explosion, became a key component of the cosmic microwave background theory. According to this theory, microwave radiation is considered the most ancient remnant of the universe. By observing these microwave radiations, we can hope to uncover the mystery of the universe's origin. However, for a long time, scientific research on cosmic microwave background radiation remained confined to the realm of theoretical physics, and precise measurements of this radiation had yet to be achieved. It wasn't until 1948, after a series of thorough surveys and studies, that scientists finally determined the temperature of cosmic background radiation to be 2.8 degrees Kelvin. This discovery marks a significant leap forward in humanity's understanding of the universe. After the Big Bang, matter gradually coalesced and transformed, generating diverse sources of heat. These heat sources could guide us in uncovering the mysteries of the universe. Based on this theoretical foundation, when scientists mapped the cosmic thermal radiation, they observed a slight temperature difference between the two ends of the Milky Way. This difference makes many suspect that our Milky Way is being pulled by some mysterious force. Not until the 1980s, when scientists began studying the phenomenon of celestial bodies shifting their orbits. They accidentally discovered a large number of ancient galaxies located toward the constellations Centaurus and Hydra. They collided and released an immense source of energy. This discovery has sparked speculation among scientists about the possible existence of an extremely powerful gravitational source in the area. The astonishing thing is that this enormous gravitational pull lies on the same visual plane as our Milky Way galaxy. This enables scientists to continue deeper research in the coming years. But because there were too many layers of shielding, they couldn't uncover the mysteries within. By observing the motion of neighboring galaxies, scientists have discovered this gravitational anomaly located approximately 150 to 250 million light-years from Earth. And the energy released from it will affect neighboring galaxies within a range of up to hundreds of millions of light-years. It wasn't until September 2014 that scientists recorded a major breakthrough in the exploration of the Great Attractor. By determining the radial velocity of the galaxy, they discovered the Laniakea supercluster, a colossal structure comprising thousands of galaxy clusters. An estimated 100,000 galaxies, each comparable in size to the Milky Way, exist within this entire supercluster. Its diameter is approximately 520 million light-years. This means the immense gravitational pull from the central point has influenced the orbital paths of celestial bodies within a 260 million light-year radius. That enormous energy source has captured special attention from the scientific community. Those who wish to discover what it is and why it possesses such extraordinary power. These questions are currently a hotly debated topic in the astronomy community. Currently, the academic community has proposed several perspectives to explain the nature of these immense energy sources. The majority of researchers believe this force is highly unlikely to originate from a black hole or any other celestial body. Based on previous observations, we know that supermassive black holes often exist at the centers of galaxies. For example, Sagittarius A is located at the center of the Milky Way. The gravitational force it generates can influence the motion of all the stars in the galaxy. However, this common phenomenon does not seem to fully explain the nature of large-scale gravitational points. According to astronomical observations, to generate the motion of a large number of superclusters within a collision range of up to 520 million light-years, the mass of the attractor core must be at least 20,000 times greater than that of the Milky Way. This mass certainly exceeds the attainable limit of a black hole. If the black hole isn't the cause of that great attraction, then perhaps this gravitational force is generated by a galaxy cluster itself. According to observational results, the mass of the Coma galaxy cluster shows a significant discrepancy from the initial estimate. The place believed to have an extremely strong gravitational pull and enormous mass, there should logically exist such a powerful point of attraction. Therefore, the gravitational force from the Coma cluster cannot be the cause of the great attractor. Then which galaxy cluster could contain such an enormous energy source? Based on the motion signals of neighboring galaxy clusters, the Lynx supercluster, located about 650 million light-years from Earth, may possess such an extraordinarily powerful gravitational force. Researchers estimate that this galaxy cluster could have a diameter of up to approximately 4 billion light-years. A massive galaxy cluster like this could even be the origin of the Great Attractor. Although it cannot be confirmed with certainty, they could potentially weigh 20,000 times more than the Milky Way. The Virgo supercluster is considered the largest known gravitationally bound structure, capable of generating an extremely powerful gravitational pull. However, it must be emphasized that humanity's current understanding of the origin of the great force of gravity remains very limited. And this is just an assumption. Despite possessing such astonishing power, the main attraction remains. However, this will not seriously affect the operation and overall stability of the universe. This occurs because galaxies and cosmic structures form during the evolution of the universe. And it adapts quite harmoniously to the presence of a major attraction. When a sufficiently strong gravitational point appears, it must still obey the universal laws of physics and maintain force equilibrium. Although we still cannot fully explain the true nature of the Great Attractor. But thanks to technological advancements and the ability to observe from more perspectives, one day, we may finally unravel this mystery.